Okay, so hello everyone, and thank you for joining another of the CMCC webinar series. So today we'll be touching a topic that is going to be covered by Shouro Dasgupta. So he's going to be talking about climate change and gender gap in South Africa. So Shouro is a researcher here in CMCC, part of the CIP division here in Venice, and also part of the Ca' Foscari University of Venice, and also of the European Institute of Environmental Economics. So this webinar is going to be moderated by me, so Arthur Senfelder. I'm also part of the CMCC, part of the RAS division, and also the Ca' Foscari University of Venice. So before we start the seminar and the webinar, just let's talk a little bit of CMCC. So what is the mission of CMCC? So CMCC mission is to investigate and model our climate system and its interactions with society, to provide reliable, rigorous, and timely scientific results, which will in turn stimulate sustainable growth, protect the environment, and develop science-driven adaptation and mitigation policies in a changing climate. CMCC has a network of seven. It's present in 7 cities around Italy. So right now we're located here in Venice, where we're transmitting this webinar, but we have also offices in Bologna, in Lecce, Sassari, Viterbo, Capua, and Milano. Divisions, we have 9 divisions spread around the cities. So the divisions that are involved here today in the presentation of this webinar are the ESEF division, so the economic analysis of climate impacts and policy, and also the risk assessment and adaptation strategies from my side, from the moderator side. So CMCC Foundation touched several different topics of research, so ranging from modeling, policy adaptation, to, for instance, hydrogeology, forest simulations, ocean ecosystems, computing, and services. So it's a very broad range of topics that we touch here, and everything is related, of course, to climate change. Regarding the outreach, or how you can actually see and read some of the work that we do, of course, the main part that we do is scientific publications. So you can see and you can find a lot of our publications in several different journals that you can find on the web. We also organize events. So for instance, this webinar is one of the events to organize. We also can organize workshops, which are parts of projects and so on. And of course, about communication. So you can also find some of our outreach activities in our channels in YouTube, Facebook, Twitter, and also Instagram. So before passing the floor to Shouro to continue with the presentation, I just wanted to say that we are open here, of course, to questions and answers. To pose your questions, please use the questions tab that you have here probably on the right side bottom of your screen. So there's a small tab written questions, and please don't forget to put your name and affiliation so we can also identify who's asking the questions. And that's it. So I give now the floor to Shouro.
Good afternoon, everyone, and thank you, Arthur, for the introduction, not only for myself and CMCC. So today, as Arthur said, our focus is on climate change and gender pay gap, but you will see that the title is only part of the story. Our focus on this paper is on the big picture, how climate affects the overall welfare in South Africa. This is sort of one of the seminal papers that has been written by Ejumeglu, an author in the Journal of Political Economy. These authors look into how women's wage structure changes during wartime. Our focus is slightly different, as you can already see. It's on some climate change, but in our case, climate change actually reduces female labor supply. So that's sort of a preview of the results you are going to see as we continue on this story. I would like to say that this paper is rather technical. I will try to provide as much details as possible for everyone, but the good thing is, because it's a bit rather technical, it'll be also short, allowing you to ask questions or continue with your beautiful day wherever you may be. So, climate change and economic productivity. We know some of the sectoral impacts of climate change. There are economic losses due to weather shocks, lower agricultural productivity, And of course, we have seen in the literature that nonlinear impact of temperature on productivity is rather evident. Going a bit deeper, climate change also affects labor, productivity, and supply. This is due to mostly health loss due to severe weather shocks. But again, we see throughout the literature nonlinear and heterogeneous impact of temperature on labor supply and labor productivity. So moving on with our story, what are the research questions we proposed in today's presentation? Of course, to begin with, how to model climate damages within the shared framework, the SSPs. What drive wage dynamics under the various SSPs? And of course, how to different climate damages, that is the representative concentration pathways or the RCPs, impact relative wages. So these are the basic questions that I'd like to propose to you as we go on. As we move on, this is the approach we take. In this paper and the other papers that we are working here in the ECHIF division, we are trying to combine high-resolution climatic data with microeconometric surveys and then use the econometric estimations in a sort of OLG framework. So our approach, part one, we estimate the impacts of warming on labor supply using panel econometric methods and microsurveys. We use the estimations to parameterize or calibrate an overlapping generation or an OLG model to account for demographic changes and wage dynamics. The OLG model in the third step is used to project the wage dynamics under various SSP and RCP combinations, so under various socioeconomic and climatic combinations. Moving on a bit more. So as I told you, we combine microeconometric estimates using a longitudinal household survey across all the South African provinces. So it's a nationally representative survey. I will come into details of the survey the survey data we use. And it's a nationally representative, covers all the provinces and provides and accounts for the rural-urban difference or division across South Africa. The OLG model is an analytical model that we use to project the future impacts of climate change on labor supply, and of course to study the evolution of gender pay gap under various climate change scenarios. The microdata is the National Income Dynamics Survey. So far, 5 waves have been conducted from 2008 to 2017. It is conducted by the Southern African Labor and Development Group, or Development Unit based at the University of Cape Town. It is a brilliant data set. It covers everything from household income expenditure to labor supply to health status of the respondents to impact of shocks, both financial and weather shocks. So the table below you can see, we have computed the wages by gender and by the skill level. So we use the low skilled, high skilled, and services, and of course differentiate by the gender. I will come into the distinctions in a little bit, but the interesting thing in South Africa is that even in the services sector, the wage gap seems to persist. Whereas in many other countries, the evidence suggests that at least in the services sector, the wage gap either diminishes or at least closes. This is something that is not evident from this survey in South Africa. As I mentioned, the needs data set provides a lot of information, and a part of the information is dedicated to the occupational information among the respondents. So NIDS provides information on 10 occupational codes, but we recategorize these codes for the primary occupation, and we recategorize them into 3 sectors. So the first is low skilled, which consists of agriculture, hunting, forestry, fishing, mining, quarrying, and construction. Then we use a second sector called high skilled, which is manufacturing and utilities. And of course, the third sector that we don't talk a lot about in this paper is services. And you will see why we don't talk a lot about this paper. But the services sector consists of everything that can be considered services and cannot be included in either low skilled or high skilled. So the climate in South Africa is rather heterogeneous. South Africa is a large country. The map shows the maximum weekly temperature in degrees Celsius by the provinces in South Africa in 2015. The white spot that you see in the middle is Lesotho. South Africa has a country within itself, so that's why the data for that is not available. But the interesting story coming out of this slide is the heterogeneity of the maximum weekly temperature in a given week in South Africa. And as you can see, there is a lot of differentiation. So I'll move on with the econometric framework to begin with. You will see that we use two econometric estimation strategies for this paper, which we use to calibrate the analytical OLG model. The first model consists of the labor supply component of our study. Here, our dependent variable is the number of hours worked in a given week, the given week being the week that the respondents were interviewed in. Our primary covariate of interest is, of course, the maximum weekly temperature. In line with the recent literature and the development in the literature, we use a nonlinear framework. So we use the maximum weekly temperature and the square term of the weekly temperature to account for the nonlinear relationship of temperature and labor supply. And of course, we control for a whole host of individual level covariates, including age and its second degree polynomial, race of the respondent or the worker, the health expenditure in the last 30 days, that is whether the respondent had to spend anything related to their health status. We also include province and weekly fixed effects to control for, let's say, spatial and time invariant and time variant factors. We also include a year into season fixed effect, and of course, a temperature and province interaction term. This particular econometric estimation or identification framework to study the impact of temperature on labor supply is estimated separately for low-skilled and high-skilled male and female workers. So we really try to make a distinction between not only the gender, but also their skill level. Moving on, this is the empirical results from the estimation strategy that we just saw. So on the left-hand side, we see how the temperature level affects the female workers in the low-skilled sector. On the right-hand side, you see how temperature affects the male workers in the low-skilled sectors. Our finding suggests that labor supply for men is maximized at a weekly maximum temperature of 27.6 degrees Celsius, but almost 1 degree lower for women. So this is concerning. As we saw before in South Africa, women earn much less compared to men. But of course, our econometric estimation shows that their threshold temperature, which maximizes their weekly number of hours worked, is also lower. So the story out of this particular slide is that there is a maximum weekly temperature which optimizes the number of hours worked for both men and women. But the optimal temperature is higher for men, but almost a degree lower for women. So women's decline in labor supply comes at a much earlier temperature level than men. So the second part of the story is that once the optimal temperature is reached, any incremental increase in maximum weekly temperature leads to a decline in labor supply, as evident from the inverted U-shaped curve. Now we're going to move on to the second econometric strategy in this paper, where we look into income. It is largely similar, but instead of weekly wages or weekly number of hours worked, we look into log of total monthly individual income. So now we are looking into the nonlinear relationship of temperature and monthly income of a respondent. Almost all the covariates that we controlled for in the last regression remains the same. Of course, the dependent variable is changed from number of hours worked to log of total monthly individual income. And of course, we still control for the provincial and the weekly fixed effects, precipitation, age and its second degree polynomial, race, and the health expenditure dummy for the individual. And of course, again, we estimate this equation or regression separately for low-skilled and high-skilled male and female workers. Moving on to the results for this part. Income to temperature response functions of both male and female workers in both sectors have varying slopes. So this is more to show that even the income of male and female in both the sectors are a response differently to temperature. This difference is particularly significant in the low skill sector. As you can see, there is a large difference in the two response functions. But in the high skill sector, which is on the right hand side of your screen, is slightly closer, actually much closer. So this brings us to a close of the first part of our paper, essentially. Now we're going to use these econometric results to calibrate our OLG model that you're going to see shortly. So some of the OLG model assumptions. This is based on the unified growth theory by Galler's 2011 paper, and of course the demographic climate model by Cassie in 2019. Our model is much simplified than our econometric strategy. There are only two types of labor, low skilled and high skilled. So you can see that why we don't talk much about services in our paper. And it only has two sectors, agriculture and non-agriculture. Agriculture sector uses low skilled labor, whereas the non-agricultural sector uses only high skilled labor. There is low substitutability between the two types of goods in order for labor to reallocate towards more damages, towards the sector which will be more damaged by climate change. And of course, in also the region where the demand is going to be higher. If you're really interested in this, I suggest you look into Desmet and Rossi Hansberg 2015 paper. They lay out a beautiful story and solve everything to make things much clearer than I have time today. So a little bit more information on our OLG model. Individuals live for 2 periods and can either be high skilled or low skilled. So it's very simple. In the first period of their lives, the individuals are children, and the only thing they consume is parental time. In the second period of their lives, they will be assigned to each of the two sectors based on their skill level. Adults will work, consume goods, and of course have children. The objective of each individual is to maximize lifetime utility of consumption and their children's future well-being by making decisions on education and consumption. The child rearing costs are different for children with different skill levels in different regions. These are some of these. So I've laid out the assumptions that we made in our paper. Now comes the fancy equations that my first author of this paper has solved. So again, utility is based on current consumption, the number of children an individual has, and of course availability. And of course, expected wages of children. There is a budget constraint, which depends on child rearing costs and the wages of the parents. Consumption is based on, of course, elasticity of consumption. The consumer's also optimization problem is depending on the price of the agricultural good and price of the manufacturing good. We use a linear production model where climate change impacted productivity is taken into account. And then this is solved to reach the equilibrium condition. I will not spend much time on this due to my time constraint today. And then we combine the SSP concentration data with a simplified climate model, which provides us with this nonlinear productivity and temperature damage function. Again, we use the setup from Desmet and Rossi Hansberg's 2015 paper. So the goal behind showing you all the fancy assumptions and the equations was to show that, yes, we ran our econometric estimations separately on male, female, and by the skill level, but our focus in this paper is really on the big picture. We really would like to understand how climate affects, taking into consideration the gender dynamics, and the differential skill levels affects the overall welfare in the future. And this is something we're going to try and tell you in the next few minutes. So, as I mentioned before, we combine various climatic and socioeconomic scenarios. Our model that I just described is calibrated to replicate population projections under the SSP2. SSP2, as many of you know, assumes average economic growth with medium changes in socioeconomic variables. In addition, we analyze the evolution of labor market under 4 RCP scenarios. So we look into this evolution under RCP 2.6, 4.5, 6, and 8.5, which is the extreme climate change. The plots you see at the bottom of this slide shows the climate and socioeconomic projections for South Africa under SSP2 and the 4 RCP scenarios. You can ask questions as I go on. So we study 4 cases under the framework that I showed here. The 4 cases start with number 1, where we have no climatic change. This is the baseline. Climate conditions remain unchanged throughout the century. Case 2, we only have sectoral productivity damages. Essentially, climate change only impacts the productivity of sectors without altering labor availability. Case number 3, labor availability damages only. In this case, damages to availability of labor in each sector occur without any damages to the sectoral productivity. And finally, the joint case, or case 4, where we have both sectoral productivity and labor availability damages. Essentially, the impact of climate change is felt on both sectoral productivity and labor availability simultaneously. So this is the more real life scenario. If we have all digested the information, I'd like to move on to results. So again, this might be too many plots in one screen for all of you, but the left-handmost column shows relative productivity of non-agriculture to agricultural sector. The middle column shows relative availability or labor supply of high-skilled male to female labor. The third column shows relative availability of or labor supply of low-skilled male to female labor. But again, we'd like to really look into how these damages can be put into a story, right? So this is what we come up with in our results. Under the case where we only have sectoral productivity damages from climate change, welfare or overall welfare in South Africa falls by more than 5% under RCP 8.5 by the end of the 21st century. In case number 3, if you remember, where we only have climate damages on labor supply, overall welfare declines by 6.5% under RCP 8.5. And the final case, which is the joint case where both labor availability and sectoral productivity are damaged due to climate change, the overall welfare loss amounts to 11.3% under RCP 8.5 by the end of the century in South Africa. As you can see, we expect our results suggest that the damages to overall welfare, which is the true focus in the big picture, will be significantly high in South Africa due to climate change. So, as I said, I will keep this short. In conclusion, what we find is that climate change impacts really has differentiated effects on labor supply and sectoral productivity in South Africa. We see a skill effect. Higher relative sectoral damages results in more demand for labor in a particular sector. So there is a real switching effect between the sectors. So in the low-skilled labor or the agricultural sector where we are expecting more damages, labor switches to that sector. We also see a wage effect, decrease in labor availability, which results in an increase in the relative wages of female labor, closing the gender pay gap. But as we come to a conclusion of the paper, I would like to draw your attention to the relative weaknesses of the paper, which also paves the way forward for future studies. What we do not do in this paper: comparative analysis of countries with different sectoral productivity and labor availability characteristics are not taken into account. That would be the ideal case scenario. We do not account for equal pay policies. This is something significant. This is something really significant, and that is something we do not take into account. Of course, there are other researchers likely working on this. And of course, we do not include migration in the model. With this, I would like to thank you and finish my presentation and give the floor back to Arthur.
Okay, thank you, Shouro. So just to highlight here again, so questions can be posed here on the right side. There is a tab called questions. So after this this very nice presentation, so please feel free to ask the questions. So feel free to ask any questions. Sorry, some technical difficulties here, but everything is fine. And so basically, I have a question here for you, Shouro. If you don't mind, I can start with it. So basically, it's a very interesting work that you shared. So and it actually like shows and I would say supports this kind of analysis of gender pay gap and the gender, let's say, problems that we have under climate change conditions. So this is very interesting. I was wondering if you see the potential of actually expanding this work also to other countries, because this paper that you showed, this work that you showed, focused on South Africa. Do you think it's doable to expand to other countries, or do you think like the methodology is kind of restrained a bit to the data that you have? Because the data set seems to be quite robust, the one that you have there in South Africa.
So thank you, Arthur. It's a very good question. So our framework, or both our econometric strategy and the analytical model, is flexible enough that we can fit this in for other countries. And I do believe that there are data sets available, microsurveys available for a number of other countries that we can work on. So of course, the two researchers, myself and the first author, Sohail, our focus has been more on overall labor supply, and this is something we are trying to replicate for a few other countries already, not necessarily focusing on gender, but climatic impacts on labor supply.
Okay, that's really interesting. So I have a question here. Let me just open that. So it's a question from Pamela Campa from Citi. So she's asking if should we think that changes in labor supply across the, it's not scrolling here. Just a second, I can only see part of the question.
I can read the question.
Can you see that, Otavia? For me, it's really blocked. I cannot scroll down.
Yes. So Pamela is asking, should we think that changes in labor supply across the two sectors are correlated? In other words, due to climate change, low-skilled jobs will become relatively less attractive because of the additional burden of exposure to high temperature. And in the long run, there will be a movement of labor supply from low-skilled to high-skilled sectors due to climate change. Here I am assuming that high-skilled jobs are less affected by climate change.
Thank you very much for the question. That's very interesting. So this is what we expect, right? That people will move from low skill to high skill sector. But if you remember, in our model, based on economic theory, labor will move to the sector with higher damages, where the demand for labor will significantly go up. So because in agriculture, we're expecting that damages will be higher, female labor supply in general will tend to increase in that sector, but overall labor supply will decline.
Okay, thank you. I think that Arthur can start, can go on with the moderation. Arthur?
Okay, thank you, Otavia.
No worries.
So now I could actually find a way to read the questions. So if anyone has any other questions, please just post here, so I can read it now. So kind of solved a little bit the technical problem. So sorry about that. Well, in case we don't have any other questions, I would just ask Shouro to, gently to just pass to the next slide, so we can show what are the next dissemination activities that we can have from the webinars. So the forthcoming CMCC webinar is going to be on the topic of forecast of evapotranspiration and fundamental information for agricultural irrigation management. So this is going to be presented by Richard Snyder from UC Davis, which is going to be who's going to be introduced by Donatella Spanna, and also the moderator is going to be Serena Marras. Also, you can see like the recording of this webinar that we just saw, presented by Shouro Dasgupta. It's going to be put in YouTube, and you can follow all the other activities that that we have in our channel, so Facebook, Twitter, and so on, the ones that I mentioned before. So I thank you, everyone. I thank particularly Shouro also for this very interesting webinar, and please follow our activities. So thank you.
Thank you, everyone.
Sorry, Arthur, I think there is another question by Pamela. Can you read it?
Sure. Yeah,
yeah, she just wrote, yeah.
Let me see here. So, so she has actually two more questions in here in the same. So let me see. Let me just try to expand a bit if I can, because I'm still having some troubles. Okay. Otavia, I cannot see everything. Can you read it? Because for me it's still blocked. Sorry about that.
No worries. So Pamela is asking two more questions. One is, what are the channels through which you think that labor supply responses differ by gender? I guess one channel would be health effects of raising temperatures. However, another effect probably would be compositional, in the sense that men might be more likely to be found in sectors where labor supply increases with temperatures, for example, firefighters. I am just curious about the channels that you have in mind.
So again, it's a very, very critical observation. So of course, the health effects is something we essentially saw, the physiological differences between men and women. And the second one, you have already identified. The third could be underlying wage dynamics in general. So that's the third channel that we foresee that climate effects will flow into the compositional change in labor supply in the future. Otavia, I think there is another question.
Is there?
No,
let me see.
Two questions, no? I thought
yeah, but I think either she is still writing it, which is a possibility, or she didn't put anything else anyways for now. So maybe we just allow a couple of
absolutely.
Yeah, 1 minute, and then if not, we can close.
Yeah, I agree.
Okay, Arthur, I think that we can close, and anyways, all questions that are going to be posed will be forwarded to Shouro. So no worries if we don't do it now. Okay, Arthur, I let you finish.
Thank you, Otavia. So further questions can also be sent about this webinar. So here's this email, so webinar@cmcc.e. So you can send questions to this email as well, like Shouro can answer, and basically that's it. So I thank you everyone for the audience, and it was very nice. And thank you, Shouro, for the presentation for this.
Thank you, Arthur, for the moderation, and Octavia for organizing this, and everyone that joined in. Thank you.